All right, Data, welcome to the last day of videos and learning of your senior year in data analysis. You have a final project to do. I'll have that for you tomorrow. Hopefully that'll be some fun. I know you laugh when I say that, but I think it actually will be something you'll have fun with because you might get a bonus point if you show me that you're having fun. Why can't scientists trust atoms? Why can't scientists trust atoms? I don't mean like ADAM atom, I mean ATOMS atoms. Why can't scientists trust atoms? And the answer is because they make up everything. I need the little drum thing. Boom, boom, boom. Not very funny. All right. What are geometric probabilities with shapes? We're going to talk about shapes now and geometric probabilities. So I'm going to say, what's the probability? Now I'm going to think about this as this is a big, board, and like think of it as like a chalkboard, right? And you're standing back there in a classroom, and I give you a tennis ball, and you get to throw it at this board. It's going to hit in a random spot here, right? You close your eyes, throw the board, and what are the chances that it hits in that little square? All right, so what are the chances it hits in that little square? So I'll shade it. Probability that hits in the square. Right? Now, remember, it can only hit in the rectangle. That's that's the chalkboard, right? Or maybe that's the whole wall. So it has to hit that wall somewhere. So let's just say you're a good enough shot that you can throw the tennis ball, it'll hit the wall somewhere. But the question is, what's the probability it's going to fall in that little square? Okay, so what we need to do is we need to find successes over total. And in this case, it's going to be successful area over total area. That's what we're going to look for. So my successful area. My successful area is the probability hits in that square. So that is 2 by 2, because the area of a square is its length times width, 2 by 2, divided by total area. Total area was the whole wall, 22 times 5. If I put that all into my calculator, I should get an answer. So on top we have 4, 2 times 2, divided by, put parentheses around it, 22 times 5. Voila. There is a I guess I'll go this way. 3.6% chance that the ball is going to land in that little square out of the whole room, okay, or the whole wall. That is how you do geometric probabilities. Let's try another one. And by the way, you really only need 2 formulas. First formula is length times width, works for any square or rectangle. And then you need to know the formula for area of a triangle, which is length times width, or base times height. We have to divide it by 2. I'll do one right now for you. So what's the probability that you throw at the same wall? You're in my classroom. You chuck tennis balls at this wall. It's going to hit that wall. It's a terrible rectangle, but you get the idea. It's going to hit that wall. And I know they're in centimeters, but just pretend. What's the probability that's going to hit this little triangle, right? Because it's randomly going to hit somewhere in that wall. What's the chance it's going to hit that little triangle? So probability is going to hit the triangle is going to be success over total. And that's area, right? So successful area of a total area. So the successful area is a triangle. The triangle is 1/2 base of the triangle, 8 times height of the triangle, 5. That's my successful area, divided by the total area. The total area is the wall. Okay, putting that all into my calculator. 40 divided by 2 is 20. 20 times 8 is 160, so that's 1/8 if I reduce that down, 0.125. So you can leave it at that, or you can change it to 12.5% chance. You can do it either way. Up here I want percentage, here I want decimal. Both are acceptable and good to go. All right, the last type of problem you need to know how to do is right here. Now, no tearing up. This is the last problem I'm probably going to explain to you as a senior at Homestead in data analysis. All right, so don't get all upset on me here, or don't applaud too loud. So what's the probability? Let's do the probability that it lands in the rectangle. Yes, this is the probability of the rectangle. Okay. So here's the wall, and you're chucking tennis balls at the wall. So probably it lands in the rectangle. Well, that would be 3 times 2 on top, because that's where I want to hit, divided by the total, 12 times 8. So that's the probability of it hitting in the rectangle. So I have 6 divided by 12 times 8 is, I believe, 96. I'll prove to you That's the case. Oops. Let's go 12 times 8. Whoa. Mr. Manners, slow down. I guess you can't see the calculator, can you? Go to, maybe you didn't, 12 times 8 is, I am really struggling. Maybe I am the person who's getting all upset here because it's, 12 times 8 is 96. So 6 divided by 96, 0.0625. So 0.0625. So the probability of that ball hitting the rectangle is 0.0625. Well, what if I changed it? If I said, what's the probability that it hits the rectangle or the triangle? Probability of rectangle or the triangle. Well, the rectangle and the triangle are my successful areas. So the rectangle is 6 plus, because that area of the rectangle is 6. The area of this triangle is 1/2 base times height divided by the total area, which is going to be 96. So remember, when there's an or in here, that means just put a plus sign and you're good to go. All right, so we did rectangle or triangle divided by the total. So that's going to be, so let's do 6 plus half of 2 times 2 is 2. So 2, so that's 8 divided by 96. My percentages had to go up because I have a bigger space here, right? I have a better chance of hitting when I add both squares in. So 8.3% chance of hitting in the rectangle or the square. What if I said, this is a tough one, probability of not the rectangle or triangle. I said square earlier, I meant rectangle. Rectangle or triangle. So probability that I'm not hitting in the rectangle or the triangle. Okay, so I'm not going to hit in those, which means I need to find all of this area out here. I'll dot it because I used some shading before. So probability that I hit in all that area out there. So we need to find that area. That'll be our successful area. So to find that area, what I'm going to do is I'm going to take the whole area, 96. Got to find the success, right? My successful area is all that area. I'm going to take 96, the whole area, subtract the rectangle, subtract the triangle. So I'll say that again. To find the dots, the dotted area, I'm going to take the whole area, subtract the rectangle, subtract the triangle, and I'm going to have all the dots. That's my successful area. So this is 88. That's going to go up here on the top. And then I'm going to divide it by the total area. That never changes. As you've seen, every denominator, always 96, 96, 96, all the way up on these problems. 88 divided by 96, which is going to be quite a bit. There's a pretty good chance that when you throw the ball at the board that it's going to hit in the rectangle, but not in the triangle. I'm sorry, the big rectangle, but not the little triangle, little rectangle or little triangle. Boy, I'm getting all over my words here. 91.7% chance that it's going to hit in those. Now, some of you may be realizing something. What's kind of crazy about this number and this number? I think there's something going on there. I think they add up to 100%, and they should add up to 100% because this was probably a rectangle or triangle, so that was these two. Well, this is the probability of not those two. So if I do rectangle or triangle, the not is just going to be no work. You don't even have to do all the work. You could just take 100%, subtract 8.3, you will get 91.7. You've done it. Go do your worksheet, and really it's just yesterday's worksheet, just finishing it up. And then your exam project is coming tomorrow in place of a final exam. And you can turn it in over the weekend so I can grade it in case you need any corrections. Have an awesome day. We'll talk to you soon. Bye.